Right, I'm going to refine paper 1 from your spring mocks. Question 1, work out the distance between -3, 7 and 5, 1. I'm going to sketch those points, -3, 7 and 5, 1. So I want to find this distance. To do that, I'm going to use Pythagoras. The change in y from 7 to 1 is 6. The change in x from -3 to 5 is 8. So to find this length, I'm going to do the square root of the two shorter sides added together. 6 squared plus 8 squared gives me the square root of 36 plus 64 is the square root of 100 is 10. It has to be positive because it's a length. Question 2. Work out an expression for the rate of change of y with respect to x. This rate of change of y means dy by dx. So I'm going to find dy dx. Before I do that, I need to expand my bracket. So y is 2x to the 5 minus 7x to the 4. Now I'll differentiate. dy by dx is 10x to the 4 minus 28x cubed. Question 3. Here are 4 graphs. Circle the letter of the graph that represents 3x plus 2y equals 5. I could rearrange to make y the subject, so I'd get y equals -3x plus 5 and then divide by 2. So it's got a negative gradient, so it's going to be b or a. They are the only ones with negative gradients, and a positive y-intercept, so it is b with the positive y-intercept. Question 4. The function f is 3x minus 5. The range is given by this, 13 to 19. Work out the domain. Range is everything to do with y, or everything to do with f of x. Domain is everything to do with x. So I need to work out y is between 13 and 19. The range is between 13 and 19. Find x. So I'm going to work out what is x when this is f of x is 13. When f of x is 13, x is equal to, when f of x is 13, that means 3x minus 5 equals 13. Add 5, divide by 3, so x is 6. So x is going between 6, and then when f of x is 19, that means 3x minus 5 is 19, 3x is 24, x is 8. So x is between 6 and 8. So x is between 6 and 8. B, the function g is given by this. G of x is x squared minus 4 with a domain of -1 to 3. So x is between -1 and 3. This is a quadratic function. I'm going to do a quick sketch. It's x squared minus 4. So the graph of x squared looks like this. The graph of x squared minus 4 looks like, it's a different colour. Looks like this. It's just been translated by 4 units in the negative y direction, so -4. But it's got a restricted domain. X is between -1 and 3. So I'm going to work out what is y when x is 3. So x squared minus 4 would be 3 squared minus 4 would be 9 minus 4 is 5. So when x is 3, y is 5. And then let's see what happens when x is -1. I'll get -1 squared minus 4 is 1, take away 4 is -3. So when x is -1, y is -3. So my graph goes from -3 and then it goes down to -4 and then it goes up to 5. I can see that the maximum is 5. I'm just going to draw that bit again. I can see that the maximum value is 5. So range, this is g of x or y, g of x. So I can see g of x is less than 5 because it's less than 5. So when x is 3, g of x is 5. So if x is less than 3, g of x is less than 5. And then greater than, I can actually see the minimum value is not -3. It's not when x is -1. The minimum value is here. the minimum value is -4, and x is equal to -4. It passes through that point. So I'm going to write greater than or equal to -4. Next one. H of x, find the inverse. So I'm going to write h of x as y, 3 plus x over 2, switch x and y, x equals 3 plus y over 2, and rearrange to make y the subject. So times by 2, subtract 3, and then finally replace that with h minus 1 of x. So h minus 1 of x is 2x minus 3. 5. The nth term of a sequence is this. A term has value 5, find out the value of n. So I'm going to equate my nth term to 5 and work out what is n when the term is 5. What's the position of that term? I'll times through by n minus 1. So I'll get 2n plus 47 equals 5n plus 5. Subtract 2n on both sides. So 47 is 3n plus 5. Subtract 5 on both sides. 42 is 3n. Divide by 3 on both sides. 42, 1 is 14. So n is equal to 14. Write down the limiting value. So as n approaches infinity, so I get 2 lots of infinity plus 47 over infinity, plus 1. Against infinity, 47 and 1 are insignificant, so I'm left with 2 lots of something over 1 lot of something is 2. Here's a sketch of sine x. Given that sine 220 is negative k, work out the two values of x between 0 and 360 for which y is equal to k. So if sine 220 is negative k, so 220 is somewhere around here, and yep, I can see sine of 220 is definitely negative. So this is 220, and this is negative k. So I want to work out the value of x for which y is equal to k. So k is going to be like a mirror image in the x-axis. So here's k. So I need to work out these two values. I can see that this, I'm going to draw a little dashed line, this little distance is the same as this little distance, is the same as this little distance. 180 to 220 is 40, so that little distance is 40. These little distances are 40. So this angle is going to be 0 plus 40 is 40, so that's going to be one solution. And this angle is going to be 180 minus 40 is 140. That's my second solution. 7. Solve. I'm going to expand my right-hand side. So 2x squared plus 4 is greater than 2x squared minus 3x plus 2x is minus x, minus 3. And I am going to subtract 2x squared on both sides. So I'm left with 4 is greater than negative x, subtract 3. I'm going to show you two options here because lots of you made a little mistake with this one. Either I can add x to both sides. So I'm going to have x plus 4, I'm adding x to both sides, is greater than negative 3, and then subtract 4 on both sides, so x is greater than negative 7. The other option is at this stage, so I've got 4 is greater than negative x, subtract 3. I could add 3 to both sides, so I would get 7 is greater than negative x, and then divide through by negative 1, or times through by negative 1 to make x positive. So I'm going to get x here and negative 7 here. If I times or divide by a negative, that is one condition where inequalities do not operate like equations, because the inequality has to switch sign. So it'd be x is greater than rather than x is less than. X is greater than negative 7. Now I can see these two answers are the same, okay? So it's x is greater than negative 7. When you times or divide by a negative, you switch the sign of an inequality. Question 8, simplify. I am going to expand my bracket, so I'll get root 75 times 3 is 225, plus root 48 times 3 is 144. And I can see these are both square numbers, so 225 is 15 squared, and 144 is 12 squared. So 27, 15 plus 12 is 27. Question 9, expand and simplify. I'll expand my first two brackets, so these two, and I will get 6x squared minus 15x minus 8x plus 20 simplifies to 6x squared minus 23x plus 20, and now I'll expand all of that with x plus 2. So I'll get 6x squared plus, 6x cubed, 6x squared times x, plus 12x squared, minus 23x squared, minus 46x, plus 20x, plus 40. Collect like terms, 6x cubed, minus 11x squared, collect like terms, minus 26x plus 40. Have I done something wrong? Minus 46 plus 20. Yeah, I think that's right. No, that's correct. Okay, question 10. The first four terms of a quadratic sequence are this. Work out an expression for the nth term. I'm going to show both methods. So the first method I'm going to show is, I'm going 1. From 1 to 0 is negative 1. 0 to negative 3 is negative 3. Subtract 2. Subtract 2. So the first method I'll show is this method, where this is 2a, this is 3a plus b, and this is a plus b plus c. So 2a is negative 2 means a is negative 1. That means 3 lots of a, so 3 lots of negative 1 plus b is 1. So negative 3 plus b is 1, so b is 4. And then a plus b plus c is 0. So negative 1 plus b is 4 plus c is 0. So 3 plus c is 0. So c is negative 3. So my nth term is negative n squared plus 4n subtract 3. The other method is that you could have, do this in red. Once you've worked out a is minus 1, write the nth term for negative n squared. So that would be negative 1, negative 4, negative 9. And then underneath I'm going to write my nth term, which is 0, 1, 0. I want to go from negative 1 to 0, so I am adding 1. From negative 4 to 1, I'm adding 3. From negative 9 to 0, I'm adding 5 there, aren't I? From negative 4 to 1, I'm adding 5. From negative 9 to 0, I'm adding 9. And I need to find the nth term of this blue sequence, which I can see is going up in 4s. So it's going to be 4n. And then I like to work out the 0th term, so go back 4 minus 3, so 4n minus 3. So I'd get minus n squared plus 4n minus 3. So either method, but you should get minus n squared plus 4n minus 3. Question 11. I've got two matrices, multiply together, give me k lots of the identity matrix. Work out the values of a and b. So I'm going to use matrix multiplication to work out my left-hand side. A, B, 0, 0.4. So I'm going to do top row, left column to work out top left element. 2 times A, so 2A plus 1 times 0. Bottom row times left column to work out bottom element. 0 times A plus 3 times 0. Top row times left column to work out top left element. 2B plus 0.4, and then bottom row times times right column to work out bottom right element. 0 times b plus 3 times 0.4. Let's work out what this is. So my top left is going to be 2a. This is 0 plus 0 is 0. 2b plus 0.4, and then 0b plus 3 times 0.4 is 1.2. Okay, I know that this is equal to k lots of the identity matrix. K lots of the identity matrix 1, 0, 0, 1. So that is going to be k, 0, 0, k. I am going to compare the elements in each of these. I can see k is 1.2. K is 1.2. Now I could work out a. So I can see k is also equal to 2a. So k is 1.2 is equal to 2a. So a is going to be 0.6. And then I'm going to compare top right. I can see 2b plus 0.4 is equal to 0. So 2b equals negative 0.4. So b is negative 0.2. Okay, so a is 0.6 and b is negative 0.2. Question 12. A circle centre 4, negative 2 passes through the origin and 8, 0. Work out the equation of a circle. I know the equation of a circle is x minus a all squared plus y minus b all squared equals the radius squared, where the centre has coordinates a, b. The centre has coordinates 4, negative 2, therefore the equation is x minus 4 all squared plus y minus 2 is y plus 2 all squared is equal to, I need to work out the radius. I'll do that by drawing a little right-angled triangle here. I've gone from 4, negative 2 to 8, 0. So gone from 4 to 8. My change in x is 4, negative 2 to 0. My change in y is 2. The radius is the square root of 4 squared plus 2 squared is the square root of 16 plus 4 is the square root of 20. So my radius squared is that thing squared, is 20. Is 20. Part B. Work out the equation of the tangent to the circle at A. I'm going to jump back to here. So I need to work out the equation of the tangent. I know that a tangent and a radius meet at 90 degrees. That means they're perpendicular. That means the gradient of my radius is the negative reciprocal of the gradient of my tangent. So I'm going to find the gradient of the radius. So m is going to be change in y, 0 minus 2 over change in x, 8 minus 4, gives me 2 over 4 is a half. That tells me that the gradient of my tangent is going to be the negative reciprocal of a half is negative 2. I can see the gradient is negative, so I'm happy that that's not completely wrong. Now I'm going to work out c. So I've got y equals minus 2x plus c. I'll substitute in this point because that lies on the line. So 0 equals negative 2 lots of 8 plus c. So 0 equals negative 16 plus c. So c is 16. I can see that this line would intersect the y-axis at some positive value. So I'm happy that c is positive. So minus 2x plus 16. So y equals minus 2x plus 16. Question 13. Here's a sketch of y equals kx. 2, 3 and a 16th is a point on the curve. Work out the value of k. I'm going to substitute this point into my equation. So 3 and 1/16 is y is equal to k to the power of 2, because x is 2. I'm going to write this as an improper fraction, because I don't know how to square root 3 and 1/16, but maybe as an improper fraction I would recognise some square numbers. So 3 times 16 is 48, plus 1 is 49 over 16. Lovely. Now I've got two nice square numbers, so I'm going to square root both sides, square root numerator and denominator, and I'll get 7 over 4. Part B. B is a point on the curve with x coordinate negative 1. Work out the y coordinate of B. So y is equal to k to the power of x. I worked out that k is 7 over 4. So y is equal to 7 over 4 to the power of negative 1. To the power of negative 1 is the same as the reciprocal. Okay, to the power of negative 1 is the same as the reciprocal. So the reciprocal of 7 over 4 is 4 over 7. Question 14. Solve the simultaneous equations. Do not use trial and improvement. I'm going to show you workings. Okay, so I'm going to see if I can eliminate one of these three variables. What do I see? I see that this I see that this equation does not have b in, so I'm going to see if I could use these two equations to eliminate b, and then I'll end up with two equations that both just have a and c in. So I'm going to try and eliminate b from these two equations. I'll call them equation 1, 2, and 3. To eliminate b, I want to make the coefficient of b the same. I can see if I multiplied equation 1 by 2, I would end up with the same coefficient. I would end up with 2 lots of b. It would be negative 2 lots of b, but I don't mind about the negative. So I'm going to times the whole of equation 1 by 2. So I get 8a minus 2b plus 6c equals 54. And underneath I'm going to write equation 2. 3a plus 2b minus c equals 5. I've got the same coefficient of b. They have different signs, negative and plus. Therefore, if I add the equations, they will cancel out. Same signs subtract. If they've got the same sign, you subtract. If they've got different signs, you add. I'm going to add them together. I'm going to get 11a. Negative 2b plus 2b cancels. 6c minus c is plus 5c is equal to, add them together, 59. Okay, so I've got 11a plus 5c equals 59. And now I'm going to write equation 3 because that is another equation with just a and c. 2a minus 5c equals negative 7. Aha, lovely. I've already got the same coefficient of c, so I don't need to do anything. I can go ahead and, different signs, add. 13a equals 59, subtract 7 is 52. Divide by 13, a is equal to 4. Nice. As soon as I start to get decimal answers, that is an indication I've gone wrong. There are lots of places to make slips with these questions, but if I'm getting nice whole numbers, it's an indication that I might be on the right line. So a is equal to 4. Now I'm ready to substitute this back in to find b and c. I'm going to substitute back into, let's go with this one because c is positive. So I'll have 11 lots of 4 plus 5c is equal to 59. So 44 plus 5c equals 59. Subtract 44. So 5c equals 15. So c is equal to 3. Aha, another nice whole number. I'm feeling a bit more confident that I'm on the right tracks. And now I can substitute these values back into one of my original equations. Let's go with, to find b, let's go with equation 2. Into equation 2. So I'll take my values of a and c and substitute them into equation 2, which was 3a plus 2b minus c equals 5. So I'm going to have 3 lots of a is going to be 12 plus 2b minus 3 equals 5. 12 take 3 is 9 plus 2b equals 5. Take away 9 on both sides. 2b equals minus 4. Divide by 2. b equals negative 2. Aha, another nice whole number or nice integer. So a is 4, b is negative 2, c is 3. Work out the value of x between 0 and 90, for which 3 tan squared x is equal to 1. Lots of you use trig identities for this. You don't need to use trig identities for this. You've got 3 tan squared x equals 1. What you can do is just make tan x the subject. So I'm going to divide by 3. So tan squared x is a third. And then square root. So tan x, this is where you need to be careful, is the plus or minus square root of a third. I'm just thinking about the graph of tan. Between 0 and 90, it looks like this. So tan x is actually always positive between 0 and 90. Therefore, I don't need to worry about the negative square root. If I had a larger domain, I might need to include that. So I'm just going to take the positive square root. So the positive square root of a third. And I don't have a calculator, so I'm going to see if this is one of those nice exact values. So how else can I write this? I could write it as the square root of 1 over the square root of 3, which is 1 over root 3. Aha, I recognise that as an angle from that root 3 to 1 triangle. So the shortest side is 1, opposite the smallest angle is 30. The longest side is 2, opposite the largest angle is 90. The side in between is root 3, opposite the angle in between 30 and 90 is 60. 1 over root 3, so I'm doing 1 over root 3. Opposite over adjacent is tan. Opposite over adjacent, this side is opposite 30. So tan of 30 is 1 over root 3, or root 3 over 3. Therefore, this angle must be 30. X must be 30. X equals 30. Use the factor theorem to show that 2x plus 1 is a factor of f of x. That means if I were to substitute f of negative a half, I should get 0. I need to show that, so I'm going to do 200 lots of negative a half cubed plus 100 lots of negative a half squared, take away 18 lots of negative a half, subtract 9. Let's work out some of these. So I'm going to have 200 times negative a half cubed is going to be negative an eighth, plus 100 times negative a half squared is going to be positive a quarter, minus 18 times negative a half is going to be minus 9. So if I subtract negative 9, that's like adding 9, and then subtract 9. 200 divided by 8 is like 100 divided by 4 is 25. So 200 divided by negative 8 is going to be negative 25. 100 times a quarter is positive 25. Plus 9, subtract 9. Yeah, that's definitely 0. Question, part B. Hence solve. So I know that 2x plus 1 is a factor. I'm going to show you two ways. Either you could use inspection. So I know 2x plus 1 times something gives me 200x cubed plus 100x squared minus 18x minus 9. This, my original function. So I'm going to see if I can fill in the blanks. So 2x times something gives me 200x cubed. So this must be 100x squared. Now I'll do the number bit at the end. 1 times something gives me negative 9. So this must be subtract 9. Now I'll see about x. I'm going to look at the x squared term. I've got 100x squared. So to get my x squared terms, I do 1 times 100x squared, and then I do 2x times whatever this x term is. Well, 1 times 100x squared is already 100x squared, so I've already got it. So I think this must be 0x. I don't need any other x squared terms. Let's just check for the negative 18x term. So to get my negative 18x term, I would need to do 2x times minus 9. That would get me minus 18x. 0x times 1 is 0. So yeah, that would work. I would get minus 18x. So now I've got my 2x plus 1 and my 100x squared minus 9. I'm solving, so I'm expecting my answer to be like x equals. So I'm definitely not done yet. I can see this is the difference of two squares. So 2x plus 1, 10x plus 3, 10x minus 3 is equal to 0. Means x is negative a half, x is negative 3/10, or x is 3/10. Okay? So x is negative a half, x is 3/10, x is negative 3/10. I'm just going to show you the other way that you can get this bracket using polynomial long division, which I know some of you prefer, so I'll do that over here. So I'm going to divide 200x cubed plus 100x squared minus 18x minus 9, my polynomial, by my binomial, by 2x plus 1. So 200x cubed divided by 2x gives me 100x squared. 100x squared. Multiply 100x squared times 2x is 200x cubed. 100x squared times 1 is 100x squared. Subtract 200x cubed, take 200x cubed is 0. 100 take away 100x squared is also 0. Drop my minus 18x. Ready to repeat the cycle. 0 divided by 2x is 0, so I've got 0 lots of x. Times, I'm going to get 0 plus 0. Subtract. Negative 18 subtract 0 is negative 18x. Drop my minus 9. Negative 18x divided by 2 is negative 9 times. So I'll get minus 18x, take away 9. Nice, I get a remainder of 0. Just confirms that 2x plus 1 is a factor. So I get 100x squared minus 9, and then I can follow the same steps to fully factorise and then get my solutions. Let's have a look at question 17. X squared minus 6x plus 5 is given. draw a suitable linear graph to work out approximate solutions to this. Okay, I can see that this quadratic is a bit different to this quadratic. I've got the graph of x squared minus 6x plus 5. So what I want to do is try to make this into an x squared minus 6x plus 5, because that's the thing I've got the graph of. And then I could just see where that graph intersects with whatever the linear graph is going to be. So I'm going to compare to get from x squared to x squared, nothing there, no change. To get from negative 7x to 6x, I have added x. So I'm going to do the same on the right-hand side. To get from 9 to 5, I've added 4. So I'm going to do the same on the right-hand side. So I'm going to be left with x plus 4. That tells me when x squared minus 6x plus 5, that's the thing I've got the graph of, intersects with this line, is how I could solve this equation. So I need to draw the graph of y equals x plus 4 and see where that intersects with the graph of y equals x squared minus 6x plus 5. So I'm going to draw this graph. It intersects, so y equals x plus 4, it intersects the y-axis at 4. Have I made a mistake? I feel like it was... Oh yes, that's what I've done. My bad. Sorry, to get from 9 to 5, you need to subtract 4, don't you? Not add 4. Subtract 4. My bad. Subtract 4. So x minus 4. Apologies, y equals x minus 4. It was looking like it wasn't going to intersect. Great, I need to draw the graph of y equals x minus 4. I can see it intersects the y-axis at negative 4. So I'll put that here. And it's got a gradient of 1. So I've got the same scale on my two axes, so I can just like go along 1, up 1, along 1, up 1, along 1, up 1, etc. And connect with a nice straight line. And then I need to read off my x-intercept. I'm just solving an equation in x, so I just need the x-coordinates. I don't need to worry about the y-coordinates. It's not simultaneous equations. So my x-coordinates, it looks like about 1.75. So I'll write that for 1. X equals 1.75. And then for my other one, about 5.25, I think. So x equals 5.25. If you had sort of 0.1 either side, you'd get the mark. Here's a triangle. Use the cosine rule to find x. So I can see I've got 3 sides and an angle, so yeah, definitely cosine rule. Okay, so this side is the one that's opposite the angle. So it's going to be 7 squared equals x squared plus 3 squared minus 2 times 3 times x cos 60. It's not always x squared. It's always the side that's opposite the angle. So I'm going to get 49 equals x squared plus 9, take 6x cos 60 is a half, times a half. So 49 equals x squared plus 9, take 3x. I've got a quadratic. I'm going to get everything onto one side, so subtract 49. 0 equals x squared. I'm going to write then my x term. And then 9 take away 49 is minus 40. Now I'm ready to factorise. 0 equals, I think, 5 and 8. X minus 8. X plus 5. So x is 8 or x is negative 5. But x is a length, so it cannot be negative. So x is 8. F of x is a cubic function. For y is less than 0, x is less than 5, and for y is greater than or equal to 0, x is greater than or equal to 5. The function is increasing for x is less than negative 1. That means it's got a positive gradient. Decreasing between negative 1 and 2, negative gradient if it's decreasing, and then increasing when x is greater than 2, so positive gradient. So I think it's going to be a positive cubic by the look of it. It starts negative, positive gradient, then negative, then positive, so it's got this shape. So y is less than 0. That means I'm below the y-axis when x is less than 5. So for everything to the left of 5, I need to be below the y-axis. It's increasing when x is less than -1, and then it starts to decrease between -1 and 2. So that means when x is -1, it changes from increasing to decreasing when x is -1. So that means I must have a turning point there in maximum. So I'm going to make sure I'm below the x-axis because y is less than 0, so I'm below the x-axis. And make sure that I've got an increasing function with a turning point, with a maximum at -1. So then it's decreasing between -1 and 2. Okay, so I need to make sure it's decreasing, and then it's increasing between when x is greater than 2. So that means at 2, it turns again. It goes from decreasing to increasing when x is 2. So when x is 2, it's going to change from decreasing to increasing. So I'm going to make sure we've got another turning point when x is 2. And then I'm going to think about crossing the x-axis. So y is greater than 0 and x is greater than 5. That means it crosses the x-axis at 5. So it's going to look like this. Question 20. Miriam's date of birth is 14092006. She makes a four-digit number code using digits from her date of birth. The four-digit number she makes must not start with 0, have all different digits. How many codes can she make?